In this tutorial, we're going to take a look at factoring the difference of two squares. And the course that I wrote this tutorial for, we've also been doing some common factoring and factoring simple trinomials, the x squared plus bx plus c kind. So I have put a couple of those in here because it's also important to be able to recognize that this is the difference of squares, or it isn't, or this is trinomial squaring, or it isn't. So that's why there's a few of these in here too. So let's start at A here. The difference of two squares is a perfect square minus another perfect square. And when I write x squared, when I say x squared, it's a perfect square because I could think of this as x being squared. And the word difference means subtract, so there's the minus, the subtraction sign. And 49 is also a perfect square because we can write that as 7 squared. So that's why this is called the difference of two squares. And the square root of 49 is this 7, so this will factor into x minus 7 and x plus 7. Now it doesn't matter which you write first, so if you want to write the x plus 7 first and the x plus 7 first and the x minus 7 second, it doesn't matter. Either of these are just as equally as correct as the other. B here, now, so as long as it's something squared, it's a perfect square. So t squared is by definition a perfect square because it's t that's being squared. 100 is a perfect square. If you don't know the perfect squares off by heart, what you can do is take the square root of the numbers. So for example, the square root of 100 is exactly 10, no decimals at all. You see 10 squared, so we're exactly 100, so 100 is a perfect square. It's 10 squared. So this will factor into t minus 10 and t plus 10, and if you want to write the t plus 10 first and the t minus 10 second, that's fine. Remember, you can always check any factoring by expanding. So for example, if I take this and expand, see t times t is t squared, t times negative 10 is a negative 10t, 10 times t would be a plus 10t, and this 10 times this negative 10 is minus 100. And these two terms are opposites, so they add to 0, so we end up with just t squared, that term there, minus the 100, which is exactly what we started with. So that's how you can check to make sure any of these work. Maybe we'll get rid of this writing. W squared plus 5w minus 50. Well, the difference of two squares is always two terms separated by a subtraction sign. So we have 3 here. I referred to the trinomial factoring. This is a trinomial. It's got a quadratic term, the w squared. This is called a linear term. It's 5 times the variable w. This is a constant at the end. So that's a classic trinomial. And we can try to factoring it by using that sum and difference method. So the sum would be 5 from the 5w, and the product would be the negative 50 from the constant on the end. So we look at the factors of negative 50, pairs of factors of negative 50. So the factors of negative 50, we could use 1 and negative 50, or negative 1 and positive 50. Also 5 and negative 10, or negative 5 and 10. You see, the product is negative, so one number has to be positive, the other negative. So that's why I've got two numbers here, one positive, one negative. Okay, one negative, one positive, same here. And the only pair of these, of the 4 possible factors of negative 50 that add to positive 5, is this one in the end. The 10 has to be positive and the 5 negative. So negative 5 plus 10 is 5, okay, adds the correct sum, and then multiply negative 50. So the correct numbers are negative 5 and 10. So we would factor this into w minus 5 and w plus 10, or if you want to write the w plus 10 first and w minus 5 second, that's okay. Remember, the reason they start with w's is, again, you can check the factoring by expanding. If we multiply this w by this w, maybe we'll do this up on top here, you get w squared. This is, if you've done FOIL before, that's the f. The outer terms, the w and the 10 would add to 10w, and then the inner terms, that's the I, negative 5 times w is minus 5w, And negative 5 times 10 is the negative 50. We have a couple of like terms in the middle here. 10w minus 5w would be 5w, so w squared at the beginning plus 5w minus the 50 gives us exactly what we started with, so it does check. So that's why these have to start with w's, because it's a w times a w that gives that w squared. And it's also what makes the w terms in the middle when we multiply the negative 5 by w or the w by the 10. That's how we get the w terms in the middle. D up here next. Now, q squared is a perfect square, and so is 9, but this has got a plus in the middle. It's the sum of two squares, not the difference. So it will not factor. So q squared plus 9 doesn't factor. It kind of looks like the difference of two squares, but it's the sum of two squares instead, so it does not factor. For E here, h squared minus 144. H squared is a perfect square. 144 is 12 squared. Remember, if you forget your perfect squares, square root of 144 works out to exactly 12. 12 squared is 144, so that is a perfect square. So this will factor into h minus 12 and h times h plus 12, or if you want to write the h plus 12 first and the h minus 12 second, that's just as good. P squared minus 16 is the difference of a perfect square and another perfect square. 16 is 4 squared. 4 times 4 is 16. So this will factor into p minus 4 and p plus 4, or if you want to write the p plus 4 first and the p minus 4 binomial second, that is just as good. In G, we have the difference of two terms, but they're not perfect squares, both of them anyway. The 20 is not a perfect square. Okay, 4x squared actually is, but 20 isn't. They have to both be perfect squares in order for this the factoring of two squares pattern to work. But I mentioned the common factoring. There is a common factor. 4 divides into both of these terms, so we can factor a 4 out. So what we do to figure out what's here is we take both of these terms and divide by 4. So here's the 4x squared and then the minus 20 both divide by 4. Now over here the 4's divide to give you a 1 here. So this will just result in x squared at the beginning. So we put an x squared here. And 20 divided by 4 is 5. Now don't forget about the subtraction sign here. So there would be a minus 5. So minus 5 in the end, close the bracket. And that's common factored. It's not the difference of two squares, but that is common factored. H up here, f squared minus 25. F squared is a perfect square. Difference, sign in the middle. 25 is a perfect square. It's 5 squared. So this will factor into f minus 5 and f plus 5. And if we want to write the f plus 5 term first, or binomial I should say, and the f minus 5 second, that's what it would look like. For I, x squared minus 121. The x squared is a perfect square. Difference sign in the middle. 121 is a perfect square. Again, you can check if you forget. 1, 2, 1. Square root of 121 is 11. We can go 11 squared. There's the 121. So it is a perfect square. So this will factor into x minus 11 and x plus 11. And of course, if you want to write the x plus 11 binomial first and the x minus 11 on the end, that's just fine. Last one, u squared minus 64. 64 is a perfect square. Maybe we'll bring the calculator over here one more time. Square root of 64 is 8. Or you could check this way. I think it's 8 squared. Yeah, 8 squared is 64. So that will factor into u minus 8 and u plus 8. Or if you want to write the u plus 8 binomial first and u minus 8 second, that's what it would look like. So there's some factoring of two squares and a couple where you have to recognize that, for example, it's actually the sum, so it doesn't factor, or this is what the trinomial factoring looks like and this is just common factoring here. And that's the end of the tutorial.